Hi, Cadence. My name is Ellsworth, and I saw your problem, and I'll take a good shot at solving it. Here we go. There's your problem. Find the half-life of a radioactive element, which decays according to the function, and it's given right here, where t is the time in years. So, we start with our original formula. A of t is how much we have to start with. A0 is the amount that we have at some time t in the future, and t is how long it's passed. Now we need to find the half-life, which is how long it takes for the sample to decay to have its original size. So if we start with A0 grams, then after we get to the half-life, we're left with A0 over 2, which is how much of our sample we have left. So replace A of t with this amount and solve the equation for t. Let's do that. So here's a replacement right here. We put it in, get rid of the A0s, divide both sides by A0. We're left with this. Now to knock the exponent down to the level we can work with, we need to take the natural log of both sides. That'll bring this negative quantity down to here. Basically, the natural log of 1/2 as well. So take the natural log of both sides. You're left with this. Divide by t on both sides. And that's what you get. Here's that expression right here. I put it in my calculator, and I get about 30.7 years. So in 30.7 years, that sample will decay to half its original size. Here are a few key insights. Half-lives are cumulative. After one half-life, the sample decays to half its original size. In this case, 30.7 years. You wait another 30.7 years, you're down to half of that, which is 1/4 the original size. Another 30.7 years, you're down to half of that, which is 1/8 the original size, and so on, and so on, and so on. Now we use 1/2 in this problem, but we can actually find any fractional or absolute amount of sample size at some given time t in the future. Or we can solve for, after a certain amount of time has passed, how much is left. We use 1/2 here, but we can do it to any sample size. If we want an absolute size like 6 grams or 34 pounds or whatever, you just put that in for A of t and solve for what t is. Or you can do like we did here, which is some fraction of the original part. 1/2 of A0, 2/5 of A0, and so on and so on. So that's a very flexible formula for solving any radioactive decay problem. So I hope you found that all very helpful, not just for this problem, but for many others that you are working with. So if you have any more problems or questions, let me know. Thank you.